Namaskar. We are going to deal with the raw silk physical and chemical and mechanical properties. We will first see the chemical properties. We will see for the action of water. The resistance of cocoon silk filament against water is more than that of wool. If cocoon silk filament is immersed in cold water, firstly it will swell and subsequently a small quantity of salts and portion of sericin will be dissolved in the water. Immersed in warm water, sericin fibroin reduces and some salts will be gradually dissolved. The rate of dissolution increases with the rise in temperature. If the cocoon silk is treated in boiling water for 10 to 20 hours, it will not only lose most of its sericin but will also weaken the strength of the fibroin. It also reduces the elongation and the color fades and becomes coarse to touch. If the cocoon silk filament is treated under high temperature and pressure, the fibroin will be affected, which will then begin to dissolve. Next, we see the action of alkalis. Cocoon silk filament is more sensitive to the action of alkalis than to the acids. If cocoon silk filament is kept in diluted strong alkali solution, the sericin may get dissolved, damaging the silk fiber. Alkalis include discernible hydrolysis upon fibroin and it aggravates with increase in the alkalinity. The extent of damage it does to the cocoon silk filament depends upon the temperature and the concentration of the alkali. When a particular kind of alkali is used, the extent of damage will be determined by the rise in temperature and the level of concentration. As for the cocoon, which is inferior for unwinding, an alkaline unwinding agent can be used to help sericin to swell and dissolve. Normally, NH4OH and NH4CO3 and Na2SiO3 etc. are used often. But while alkaline material, appropriate care have to be taken to prevent the dissolution of sericin that can deprive the cocoon silk filament of its elongation, lower of the unwinding and damage to the fibroin. The action of alkali on silk filament is chiefly determined by the concentration of the oxyhydroions in the water solution and the duration of action and the temperature. In case of the pH value is high and the duration is long, the damage to the cocoon silk filament will then be much more, and besides it may damage the silk filament. Action of acid. The resistance of natural silk against acid is stronger than that of cotton, whereas the resistance against the alkali is weaker than that of the cotton. Utilizing this aspect, we may distinguish the mixing ratio in respect of two types of mixed fiber fabrics. The silk fiber may swell and dissolve depending on the increase in the level of concentration and temperature of the acid. If cocoon silk filament comes in contact with weak acid, when the pH value of the solution is low, the level of dissolution of the sericin will also be less. The nearer it gets to the isoelectric point, the lower the level of dissolution. Sometimes a weak acid is also used, and if the pH value of the cocoon cooking medium is brought down, it will enable control of the raising of the sericin in the cocoon layer. If cocoon silk filaments comes in contact with the strong acid, it may quickly swell and disintegrate even if the temperature is to be low. In diluted organic acid solution, if the exposure is for appropriate duration, the physical properties will be intact and will not decay. Whereas in weak organic acid, it may swell and dissolve, turning like gum. In silk manufacturing industry, hydrochloric solution is used to dissolve and clear the sericin in the plugged eye holes, and As for the raw material cocoon whose layers are relaxed and defects are less, suitable amount of weak acid could be added in the cocoon cooling liquid, thus reducing pH value. This helps towards the smooth unwinding at the time of reeling. Besides, it gives a specific tension while enhancing the neatness of raw silk. Action of salts on the cocoon filament. Some salts are absorbed by the cocoon filament, blotting it, while some others dissolve the fibroin. The former includes salts based in iron, aluminium, tin, barium, etc., of which chlorides of tin are very prominent, while the latter includes ammonium solutions like oxidized copper. After having treated with salts and absorbed and blotted, if the cocoon filament is dried in the sunlight, the fibroin gets oxidized, leading it to its disintegration and results in the diminishing of its strength. Table salt has rather major influence on cocoon filament, and its quality deteriorates if it lies in the table salt solution with 5% concentration. The change in color seen in the case of fabrics which are worn often is also due to the salt content in the sweat. Action of sunlight on the cocoon filament. The cocoon filament is rather sensitive to sunlight, for the ultraviolet rays in the sunlight causes fragility of the silk fabric. Then amino acids in the cocoon filament absorbs ultraviolet rays having short wavelength. Silk fabrics absorb ultraviolet rays having short wavelength. Silk fabric absorbs UV rays more easily than any other cloths do, especially the OH base and OH base in silk amino acids and tyrosine contained in the silk yarn fibroin easily absorbs the ultraviolet rays, resulting in oxidation and disintegration. It is therefore necessary to avoid exposure to sunlight while processing as well as transporting. Next property, effect of enzyme on cocoon filament. Enzyme is a complex protein and it can cause destruction to so many living beings. Enzymes that can destroy and disintegrate protein liquid are called protein enzymes. They can divide the proteins into amino acids, break the peptide bond of the protein. Protein enzyme does not have easy impact on fibrous protein like silk fibroin, which is high in crystallinity. However, it can easily affect the non-crystalline proteins like sericin, making it low molecularized. If it is used in degumming silk fabrics, it enhances the efficiency of degumming. Practice shows that with the abandoning of the use of enzymes by the textile industry, not only the quality of the fabrics improved, but the handling also became much and more convenient. Physical properties of cocoon filament. Porosity and moisture absorption of cocoon filament. When we see this property, the porosity changes with the breed of the silkworms, the coarseness of the silk thread, and the sericin content of the filament, etc. The cocoon filament is 70 to 75% solid and 25 to 30% hollow, and therefore it can absorb air, salts, acids and alkalis, etc. It has plenty of absorption, strength and easy to dye. As regard to moisture absorption, since liquid silk has hydrophilicity and silk fibrous is porous, it absorbs water molecules from the atmosphere, and in water it can absorb water molecules. Generally, when there is saturation of humidity, absorption of humidity and resultant swelling may be around 30%, and the swelling depends upon the dryness and wetness of the atmosphere. When the relative humidity is 60%, the diameter of the fabric will swell by 3.8%, and when it is 90.5%, the swelling will reach up to 8.9%. If it is immersed in water at 18 degrees C, the diameter of the fabric swell up to 16 to 18%, while the weight goes up by 30 to 35%. Silk fiber has strong moisture and water absorption power. Moisture absorption capacity is valuable specialty of cloth material. Normally, the water content of the cocoon will be 5% more during rainy season than during clear weather. Countries have fixed the standard rate of water content as 11%. Therefore, in the raw silk trade, 140 degrees centigrade is often mentioned, which is the raw silk quantum with dryness without water. If further 11% is added, the official standard of moisture regaining capacity will be counted. The conditioned weight, also called as official quantum, equals to dry weight plus dry weight into 11 by 100 is equal to 1 plus 0.11. Number 2, specific gravity and specific heat of cocoon filament. As the cocoon filament is porous, it is rather light. Cocoon filament is lighter than wool and artificial silk. The heat released and absorbed by the fiber having the quality of 1 gram as the temperature change by 1 degree centigrade is known as specific heat. Its unit is calories per gram degrees. As the filament absorbs atmospheric humidity as well as air, since the specific heat of water is 1, being almost 3 times that of the fiber, temperature has very little impact on the specific heat of the fiber. The specific heat of cocoon filament is higher than that of the fibers like cotton, hemp, etc. It has a strong heat retention capacity and can retain huge amount of heat. Therefore, it is an ideal raw material for the clothes to be used in winter as well as in summer. Tenacity and elongation. Most commonly used indices in regard to silk fibers are absolute tenacity, relative tenacity and elongation. Absolute tenacity. The highest load that a strand of cocoon filament or strand of raw silk can take until breaks as it is elongated under fixed conditions is called absolute tenacity. The unit used is either kili or legion. The tenacity of raw silk of 20-22 denier can be around 60 to 18 grams. Relative tenacity indicated as PO. In order to express the extent of tenacity in respect of raw silk having different filament size, by convention relative tenacity is used. It is a comparison between the absolute tenacity and the filament size. The unit is grams per denier or cn by dtex. When the unit is converted to 1 kili or gram is equal to 0.91 legion. In the above formula, PO is equal to relative tenacity, that is grams per denier or cn by dtex, where P is equal to absolute tenacity gr or cn. S equals to filament size d or dtex. The elongation of cocoon filament is 13 to 18% and in raw silk it is 18 to 23%. The elongation of the wet cocoon is more while its tenacity would be weak. The elongation of silk fiber is influenced by several factors, and in order to assess the quality of the silk fiber correctly, it is necessary to understand the factors influencing the elongation of the fiber, which will enable us to sort out the problems in production. Mechanical properties of silk. Friction coefficient of cocoon filament abrasion resistance. The superiority or otherwise in terms of abrasion resistance is another important index in clothing. Wear and tear is used by friction. The frictional force of fibers can be determined using the formula F equals to micron into N plus N0, where F is equal to frictional force, N equals to the normal pressure mutually existing when two active bodies in relative motion, mu equals to friction coefficient, and NO the intermolecular action force when two bodies in motion come in contact with each other. Number 1. If the surface of the fiber in motion is coarse and have prominences, the friction increases with the increase in the directional stress. The formula is F is equal to micron N. Mutual effect of the active molecule group on the surface of the fiber. The intermolecular acting force N0 a great extent that happens only when the distance between two functional surfaces reaches near the size of the molecule or atom. The absorption of static electricity that takes place when there is mutual action among the positive groups on the surfaces of the bodies in the motion. In short, when elongation and elastic regain are good, the structure is dense, it is a good fiber with good resistance against abrasions. Its resistance against abrasion is due to its structure, like its sericin content, the density among the cocoon filament, the sizes of the silk filaments and their number, glossiness, etc. have impact on resistance against all abrasions. Now the high-speed machines are more demanding in these respects. Next point, the thermal conductivity of cocoon filament. Thermal conductivity of textile fiber is expressed in terms of the rate of heat conductance. The rate of thermal conductivity refers to scorching figure of the heat quantum conveyed through 1 meter square of the given material within 1 second when the thickness of the material is 1 m and the difference in the temperature between the surface is 1 degree centigrade. The thermal conductivity of the silk fiber is low and the specific heat is comparatively higher than the other natural fibers, and therefore it is warm in winter and cool in summer. This is because of the fact that cocoon filament is porous fiber having numerous vacuum spots capable of accommodating large quantity of air, and the thermal conductivity of air, that is 0.0202 calories per centimeter square only. Hence, if winter clothes are made of silk, warmth is guaranteed. A comparison in terms of size and heat maintained of various types of knitted materials may be seen below. Cocoon filament, sheep wool, artificial silk, silk cotton and hemp. Elasticity of cocoon filament. When external force acts upon cocoon filament, a certain degree of elongation takes place, and the extent of elongation depends upon the continuation of that force. As the external force is removed, the fiber returns to its original length without breaking. This property is called as elasticity. When we say that silk filament can be elongated of about 1/7 of its original size, it means that its elasticity is pretty high. The elasticity of fiber is of great importance in technical applications. Due to this quality, the cocoon filament, it is used in silk fabric, on silk wool fabric while making clothes.